Okay, very good. So the original title for the talk was Inextricably Linked Reproducibility and Productivity in Machine Learning, which is a bit of a mouthful. We had another title, which was called Machine Learning Today is Like Software Engineering in the Late 90s, Changed My Mind. I couldn't decide, so I kept them both. So the story this evening, it's kind of story time. I'm going to tell you a story about 20 years of software engineering and how I think we might be able to learn from that in AI and machine learning. But I kind of need to know something about who you are. So first, who am I? So I've done quite a lot of things. Now, the important thing to notice about this is that none of it is machine learning, and also none of it's big data. So I'm very curious to know who I'm speaking to this evening. I started off as a programmer. I moved into like DevOps style things, and then ended up in marketing. And now I'm here to talk to you all about machine learning. So we're going to split up the crowd. You don't have to move. Across two axes. So first is your kind of role. So put your hand up if you would call yourself a software engineer or programmer or coder.
When?
Okay, we're going to get to the x-axis soon. Good. Okay, what about ops, DevOps, IT, infrastructure? Okay, data science, machine learning, AI, big data. This is a big data meetup, right? Okay, okay, good. Okay, that gives me an idea. So some people, okay, now here's the fun one, because it's a story that takes place across time. So put your hand up if you started your career in tech in the 60s. 70s? 80s? No, that's not true. 90s? 2000s? 2010s? Okay, after 2015? Wow, okay, relatively young crowd. I like it. So I did this talk in San Francisco, and everyone in the room started their career less than 3 years ago, which meant I could basically say whatever I wanted all evening, because they wouldn't know better anyway. Okay, good, that's interesting. So I'm going to bear that in mind as we move through the story. So I want to first just put a bit of a disclaimer in. Now, we're going to be talking about software development across the last 20 years. It's going to be in a fairly facetious tone, right? This is not a scientific paper. The idea is to try and tell a story to get you to maybe relate to some of the facts and see how we might be able to apply them to machine learning. And it's important to know, of course, that at any point in time in tech, like there's a very long tail on adoption. So when I'm saying that everything was terrible in the 90s, you may be like, no, it was amazing where I worked. Well done. It wasn't in most places, right? So it's not about you. It's a team game this evening. So not long ago, software development was a bit of a mess. I started my career in the late 90s. Waterfall was then extremely cool. Anyone remember Waterfall? Did anyone actually do Waterfall rather than having heard of it? Right. Okay, good. Scars. So for those of you who didn't know, who don't know, it was kind of, I suppose you had a larger waterfall than this. So design would be somewhere, and you'd have other things like maintenance. But essentially, you'd have like a development team who would build stuff, and then they'd hand it over to a test team who would test it. And then once that was all done, they'd hand it down to operations who would deploy it, right? Does it seem familiar? Okay. Now, there are some issues with this. So I'm going to take you through the most facetious example of a company that I worked at in the 90s. So late 90s software development for me was software development without version control, which is hilarious for like so many reasons. We would like send around zips of code, or we'd have like a really neat folder structure on a shared drive with like dates and like this is like underscore final, definitely final, fuck it's Friday, this better be the last one, good, we're going home, .dll. That, 5:59. There we go. That's exactly it. And of course, you know, the problems here are kind of clear. Like it's easy to lose track. It's hard to reproduce the view of the world because you don't know what the other person's been doing. And if someone just changes a file, suddenly you don't know what changed. So it makes it very difficult to debug things. I'm going to talk more about debugging a little bit later on. Testing was fun too. This is where the whole idea of it works on my machine came from, because the tester would come in, you'd have a nightly build, or you'd have given them your DLL or whatever you're working on, and they'd come in the next morning and say it doesn't work. And you'd be like, yes, it does. And the hilarity would ensue, right? And again, this comes from the idea that we couldn't really control all the variables. It was hard for them to exactly reproduce what we were doing because maybe they had different libraries installed, or maybe they just didn't quite follow the 94-page Word doc that they needed to get everything installed and running, right? This is pre-Puppet, this is pre-everything. It's just pain all the way through. So the other problem with these handovers is that it's hard to collaborate with a team when you're not working in the same sort of cycle. So often they'd need to go away and do testing for several days, and by the time they came back with findings, you'd be working on something else that you might have overwritten, and everything was a bit crap. Now again, this is the most facetious example, but we're going to move on. Who said they worked in ops? Not very many. So throwing over the wall may still be prevalent these days, but it was much more prevalent then. The idea is that you'd create your DLL or maybe your WAR file or whatever it was going to be, and there'd be someone in a cave somewhere, and they'd get the email and they'd stick it in a Tomcat server and it'd work. But the problem here again is that they're right at the bottom of this waterfall. So they haven't seen any of the context of building it. You probably haven't done any non-functional testing, so it like works on your laptop, but now you're putting it under production traffic and everything's upsetting. And it doesn't work for them, and it's difficult for them to get back to the other silos to figure out what's happening. So the silos are an issue, but the main issue running throughout all of these is you really want to be able to reproduce the scenario that created the artifact that you're dealing with, right? In testing, you want to be able to say, what's exactly changed? In operations, you want to know what exactly has changed, what tests have been run. So obviously, I took a very facetious example. I didn't actually work at a place that did all of those, but I worked at several places that combined did all of those. But you must be thinking, okay, you're being really hard on the 90s now. We all had amazing things like Quake and Windows 98. So we were delivering software. How are we doing it? And the point is that when you've got bad processes like this and bad tooling, you can still deliver software, but it's slow. You've got to choose between speed and safety. Did anyone ever deal with a change control board? Right. Okay. Yeah. Good. Okay. For those of you who don't know what a change control board is, prepare yourselves. So you get a new requirement in, and you're like, okay, I think I know how I'm going to change the code to make this work. And then you go with like diagrams and a piece of paper, and you go to the change control board, and it's a bunch of like gray-bearded wizard types. And then you say, this is approximately how I'm going to change the architecture to implement this feature. And they say, that sounds good, go and do it. Rarely. Normally what they ask you to do is go away and make more Visio diagrams for 10 days. And everything's really upsetting. But this is very necessary, right? When you've got these handovers and when it's very difficult to reestablish actually what happened at different stages in the software lifecycle, because you need to put all these checks and balances in up front. And we're going to look in a short while at how that's changed. So what's this have to do with reproducibility? I've spoken about it a few times, but I think in the previous talk, the quote was, if you change anything, you'll break something else. Most of all of development, whether it's like DevOps work, infrastructure work, coding, anything you want, front end, you mainly change something and then figure out what you broke. Right? That's kind of how we work. And if we can't reproduce in this context simply means control the variables. Like we want to be able to know what changed and what didn't so that we can hone in on what we just broke. Because that's our entire lives. Change a line, fix 10. This is what we do. So reproducibility is core on every level of the software stack. I should say every level of the software development lifecycle. But we'll come back to that. So some of you young folk probably don't believe me when I was saying things earlier. So this isn't, does anyone remember the Joel test? You know, he made Stack Overflow and then went on to make Trello. Now he's super rich. So this is the Joel test. This was published in the year 2000. And I remember in 2005 that this was an aspirational goal for most teams. So let's just let that sink in for a minute. Do you use version control? So you didn't believe me. See, you kids with your hair still. You come into work every morning and you start every day with Git in it. These guys didn't. It was terrible. Can you make a build in one step? Like CI is very normal now, right? It didn't used to be then. You used to have nightly builds. Nightly builds are problematic because you put 100 changes into a nightly build and it breaks and you don't know where it broke. Your best strategy is a binary search. And if it takes a night to build, that's a really long process, et cetera, et cetera, et cetera. Anyway, that's just in case people didn't believe me. So what's changed, right? Sane people use version control. Most people use Git. You can use whatever you want. It's very uncommon to start any project without putting it in version control. And I would argue that's because it's just so easy now. Like, if you think you're going to try something or mess around with it, and it takes half an hour to set up the proper process, you won't do it. But Git init takes like, less than half a second. So you just do it the right way. This is very normal now. Developers are used to collaborating, right? So GitHub's huge. Git flow, all these things, we take a lot of these things for granted. A lot of this stuff was discovered kind of in the last 10 years. Testing teams have changed in that you used to have big separate testing teams. We've brought most of that into the development cycle now. So you have specialist testers, and then you typically run a lot of things in CI. And then ops are getting on board as well. So programmable infrastructure has been a thing. Started out with Puppet and that whole DevOps thing. Now it's cloud native. Right, so you see how people are checking in their Kubernetes manifests or whatever they're called, and then checking if what they've deployed is actually what's running in production. So we see how this idea of reproducibility through version control has gone all the way through the software stack. We spoke earlier about how it's difficult to make software in a situation where you can't control variables if you're getting slow feedback, but we're all very used to CI now, right? You commit, it builds something, it sends you an email if there's a problem. Now, you've still got to write the tests, but at least the framework's there for you to do it. And it's kind of expected. It's hard to get away with being a developer and not write any tests these days, or at least it is where I've seen. Continuous delivery is a similar thing, but I don't think I need to go into that. But the general shift that we're seeing here is this move. Earlier, I was talking about how when we don't have processes that allow quick reproducibility, we end up having to choose between speed and safety. And now we don't have to do that because there's been this mind shift, which is moving from mean time between failures, which is like, let's never break and put loads of checks in and make everyone want to cry. And we've moved instead to, let's just go really fast because we know we can detect problems quickly and fix them. And that was covered in the last talk as well. And this is the big change, but this has only been possible because we've started versioning the whole stack. Otherwise, it's impossible when something goes wrong to actually get back to a point where we can understand what happened. What's the idea? You get speed and safety. I was ahead of myself. So that was the setup for the talk. The whole idea is what can machine learning learn from software development? So that's been the last 20 years of software engineering. We had Windows 98. Now we've got Netflix. That seems like a good thing. Where's machine learning right now? So who put their hands up when they said they're into machine learning? 1, 2, a few. So how's machine learning doing in software awesomeness? Yes, you, sir. Slowly. Okay. Anyone else feeling brave about this? No? Okay.
It's essentially statistics. It's glorified term, machine learning.
Are you saying that machine learning is glorified statistics?
Exactly.
I would agree with that, yeah. It's much more useful as well, but it's definitely glorified at the moment.
I think the problem with machine learning, not in the software.
Not in the machine learning software itself.
What for?
Right.
The business side of that is in big fuzzy situation.
A big fuzzy situation. It is a big fuzzy situation. I'd argue that there's two big fuzzy situations at the moment. One is how we actually get machine learning models to production, and the other is what are we doing that for in the first place, yes. Right? But I can't cover the latter this evening, but we'll definitely get into it afterwards. So we've been speaking to hundreds of teams, so we're not going to talk about our product this evening. I'm going to talk about it a little bit at the end just to give you an idea of what it is, but we're here to just chat about fun stuff. If you're interested in that, we can talk about it. But because we're out there trying to sell a product that helps people to deliver machine learning, we speak to hundreds of companies, and we hear some incredible stories, which I've anonymized and will now share with you. So here are some of the quotes. In retrospect, if we'd been able to save the versions or have gone back in time to see how he got his learning rates, it would have avoided a lot of questions from the auditors. This is a bank that you know, not Starling Bank. It's a bank that you definitely know. It's a bank that you definitely know of. And they were doing a lot of their training in Jupyter notebooks and then collaborating by slacking them to each other. And obviously when the auditor turns up, that's uncool, right? Two of the data scientists who worked on that particular model have left and gone to other companies. You want to be able to see what they did and how they did it, and not that it's gone when they're gone. Because like a lot of time, you're training a model, and you've got hyperparameters, right? And you write them down in a spreadsheet, maybe in Google Docs, and I share it with you, and then we leave. And no one knows what that document's called, because it's probably called new document somewhere, because they were only going to use it for the afternoon. One model failed for 3 months, and we lost an immeasurable amount of money. Now, I'm sure they could measure it, but I think what he was trying to explain was that he didn't like it, right? So this is a large gaming company, online gaming company, almost certainly heard of them. Had a model in production that was doing something to do with billing, left it there for a while. No one's happy. I think there's 2 more. This one's good. After the last audit, I was surprised by how many problems in the audit we could have solved by keeping paper logs. But if we ask our data scientists to do this, they will leave. I was like, this guy, this is a Dutch insurer. And when we were speaking to him, he was just like, I really hate my job. he's the internal auditor for them. So again, we see here how, we were saying earlier where the git init takes less than half a second, so you'll just do it. With a lot of this stuff, it takes a lot longer than that. So they don't do it, and then this guy, loses his mind. Here's a good one, I like this. We keep our data science teams in the same room so they can track their summary statistics by talking to each other and remembering. And it's like, okay, literally in the same building, you've got a team who's doing something that looks not too dissimilar to what Google are doing. And just down the corridor, these guys are remembering. It's the Wild West right now. So anyway, obviously what I'm trying to suggest is that software has come quite a long way, but when you put machine learning in the mix, suddenly we've got a lot of work to do. So the natural question then is why? So I want to introduce this term of destructive versus constructive collaboration quickly. So we see a lot of people they'll say they're doing collaboration, but what they mean is shared drives. And we call that destructive collaboration because yes, you can collaborate, but unless you've got really fine-grained access controls, you don't actually know what changed. So you're not collaborating on the same version of the world, you're making multiple versions of the world without any mechanism to know which version is which as we've discovered, sucks. We've also noticed that testing models is rare. Now, testing a machine learning model, of course, is tricky because you can't just assert stuff. The whole point of a machine learning model is that you're giving it some information so that it will make predictions about other information that you've never seen. So you can't say asserts blue. It doesn't work like that. So instead, it looks a lot more like production monitoring now, where you'd look for it to do things that were within the realms of things you might expect. But of course, your average data scientist doesn't know how to do this, so what do? They don't do it. Deployment is very 90s because you either work in a company who, like Uber or Lyft or Airbnb, who've invested into really nice pipelines that understand how to deal with the kind of data that machine learning models use, or you're trying to get your normal DevOps team to understand why deploying these things is slightly different through their Jenkins, and they don't like it and it's difficult, or you're just not doing it and you're emailing like a pickle file to Dave, and Dave's putting it somewhere, and that's that. So, but of course, like, there are companies outside of Airbnb and Lyft and everyone else that are getting machine learning done. So how are they doing it? And it's the same thing as before. They're being forced to choose between speed and safety. And a lot of these people are betting their company on machine learning, so they'd probably rather have speed and safety. So how would we achieve that? I'm going to skip that one. You can see the one that I definitely dragged out of the VC deck. Okay, let's get back to normal again. So how do we get back? So we would argue that since version control has informed all the shifts that have made software much quicker, then we should start there with machine learning as well, right? Because without version control, you can't do CI, you can't do CD, you can't collaborate without creating different versions of the world. But there are some unique challenges in machine learning. So if I want to just spend all day messing around in Jupyter, in a Jupyter notebook, and then go home and have someone else get back to the exact state of the world where I was, it's a bit more complex than if I were doing that with Git. With Git, I'd just push it, you would pull it, everyone would be happy, right? With machine learning, often what you're doing is you're working in a slightly different way. So you might want to version control the environment. You're using a lot of different libraries, PyTorch, Keras, all this cool stuff. They come in lots of different versions, right? And they create very different predictions when you use them at different versions. So we need to version control that somehow. Obviously, we want to be able to version control the actual code or notebooks that we've used to do the training for these models. But importantly, these models have a lot of parameters. It's not like 3. It's like 50 sometimes. And some of them you just leave in a default position all the time, but occasionally someone changes one. And what most people do is they have a big spreadsheet. But the spreadsheet inevitably doesn't cover all 50. So someone makes a change to the 49th that no one's tracked, and now we can't reproduce the world again. So we need a way to track the code and the models and the hyperparameters to them. We also need to be able to track the training data, because so often we see that a model is being trained, and let's say it's going to, I don't know, like decide who to give car insurance to, and it ends up making very naughty decisions that everyone's upset about, right? So we need to figure out what happened. They're like, well, we trained it on this day with this version of the code, this version of the data, we think, but we're not exactly sure which one. And this is a big problem. It also means that if I'm working on something I want to go on holiday, now you're going to have to trust that I like correctly put Mark's big data blob underscore final v2. I'm going to Spain, .csv, right? So we can't put these things necessarily in Git. We can't put the environment in there. We often can't put the data in there because it's too big. I'm going to look at that now. So how do we solve this problem? Docker is a great, right? If you want to control an environment, use a Docker image. This is pretty well established now. You know, you get kind of the kernel plus all the libraries, you stick the code in it, everyone's happy, and everyone has the same thing. So that covers that part. Git is great for notebooks, and well, no, it's good for code. It's not so good for notebooks. But there are some issues. So what a lot of people do is they'll start putting Jupyter notebooks in there or their Python code. Now for code, Git works, and no one should use anything else. But for notebooks, they're stored in a very weird XML format, and you can't diff them and merge them, and everything becomes painful, right? So you need a kind of better solution there. And since it seems that notebooks are becoming the predominant way that people begin exploring ideas, typically what happens is they say something like, I'm going to write it in a notebook and I'll port it later. And then guess what happens? It gets deployed as a notebook. So it's important to be able to have workflows around these. Yeah, I think, okay, I'm just going to skip that point. So what we're proposing is, oh, hello. What we're proposing is, there's a proprietary tool that we sell, right? But it's based on an open source tool called .mesh. And what .mesh does is it works exactly like kind of Git, or it feels a lot like the Git CLI or the Docker CLI. You can push, you can pull, you can merge, you can fork, you can add collaborators and things like this. But it scales to petabytes. That's the point. And it understands the difference between a data file and a code file, and input parameters and output parameters. So that's what we've been working on. Now, that's kind of close to the end of the talk, because this really isn't a solved problem yet. Like we could talk about the shiny, like we've got GUIs and stuff, like they're really nice. But not everyone's going to want to buy those. And a lot of people are going to want to, I think, solve this with open source tooling. But it's not quite there yet. So we'd like to throw .mesh in the ring and say, maybe experiment with that if you're struggling with some of these problems around versioning the various parts of machine learning software development lifecycle. But what I'd love to do, if we've got time, is just find out if this resonated in any way at all with the brave souls who put their hands up and said that they were into machine learning. Just quickly look up from the phone. He's talking about me. You, sir, how do you achieve collaboration for your machine learning?
I've been obviously sending notebooks over email.
Is that? It's not a joke. Oh, it's not a joke. Okay, good. Yeah, yeah. Why would I think it was a joke?
There is the DVC, for example.
Mm-hmm.
It is
Yeah.
version control, which probably is taking steps to that direction.
Mm-hmm.
But not for petabytes.
I don't know. Is it for how big does it go? Don't know. No. Anyone else solving this in a novel way?
Not a data scientist, unfortunately. But this looks to me like that guy in the 90s source code in a zip file into DFS and expecting the diff merge or versioning to be okay now. Is this not a problem with the Jupyter notebook format, as opposed to any workflow that you need to move around it, where you have a problem with scalability, size, data that feeds in as the source of the model?
So, sorry, are there two questions in there? One is around diffing notebooks. Yeah.
Is there not an endemic problem with the notebook format?
Yes, there is. And if you pay us, you can have that, which will solve it for you. But if you don't, we'll just version your notebooks for you. Or you can just version them in Git, and we'll just track the big data files. The idea really is about trying to get a mechanism where you don't have to track all the things in the same place. But if you want to be able to track large input data alongside notebooks, alongside parameters, you want to be able to do it where in a short amount of time, I can get back to that state of the world quickly.
And talk about it.
And collaborate around it. That's right. Communicate about it. That answer the question? I'm not sure if it did.
Yeah, no, that's good.
Okay, cool. All right. Seems like we've kind of gone slightly unnaturally from me asking questions to other people. Are there any more questions?
So,
Oh, there we go.
Well, the same problem extends to the cloud in general. Let's say, like in Google Cloud, you use a ton of different services. You have everything integrated, and then like there is no innate version control there. Like if you BigQuery data set changes, or you one service or another, like there's no way to really roll back to a previous version of your cloud, or is there? I don't know, maybe I haven't heard.
No, and that's a really interesting point. So what we see happening a lot, but I'm wondering I'm wondering how this is changing, is that typically because data science teams can't always trust that they'll be able to have immutable queries of whatever data store. If we always knew that we could call back to the same data store, we'd just version control the query, and then that would be done. But what they tend to do is get massive dumps of files from all over the business and then manage them themselves. So that's kind of the problem that we're trying to solve. If you could version, in BigQuery, then you just version control the query, and then everything would always be fine. I hope they don't do that for at least 5 years. Yeah.
How do you handle data retention, that you need to delete data after 3 months or after a period of time?
Yeah, how do we do it?
Or your tool, or yeah.
So, I mean, essentially, it looks a lot like a Git log. So you can go and prune commits out if you want. I mean, they could be quite large. I mean, the whole idea of using ZFS in the first place is that it's copy on write file system. So you and I can be working on a terabyte of image data. If we were to use something like S3 or Git for large files, if I change 1 byte, I'm going to upload a terabyte and you're going to download a terabyte again. Git LFS just uses buckets. Anyway, the idea with ZFS is that if you make a 1 byte change, you only transmit the difference. So that also means that as you start creating more and more versions of the file in a single place, you're only adding the diffs as you go. But eventually, it's going to get large. I mean, if you're dealing with petabytes of data, you've got to store them somewhere. So yeah, pruning works in the same way that you would do if you wanted to go back into a Git log and remove some old commits. We can do that. And it kind of figures out how to get the internal consistency after that. But that's not something we wrote. We didn't write ZFS. Yeah.
Perfect. I think that will... is there any more questions just before we move on? Well, can we join me in a big round of applause, please, for Mark? Thank you.